Hi, today we're going to talk to you about a real life physics problem about a spool of metal rolling off the back of a truck. Now, our truck driver's had a big weekend, he's forgotten to tie down his load, and he's gone to accelerate off at 3 meters a second squared, and the 500 kilo roll of sheet metal wants to stay where it is due to Newton's first law, and so it starts to roll off the back of the truck, affecting the acceleration of the spool is its radius of gyration and its inertia. One of the conditions is that it will not slip, it will roll off the back of the truck. So now Jarred's going to tell you how he determined the angular acceleration of the spool and verified this with MATLAB. Thank you.
Thanks very much, Will. So in order to calculate the angular acceleration and the acceleration, the linear acceleration at the center of the spool, we're going to need to work out a couple of other values. One is the moment of inertia. Now, where mass is the resistance of a body to linear acceleration, the moment of inertia is its resistance to angular acceleration. We also need to work out the radius, and we have the radius of gyration, and so there's a relationship between the two that we can use to work out the radius. From there, we can work out the angular acceleration by taking the radius multiplied by the mass multiplied by the acceleration of the truck, and divide that by the moment of inertia plus the mass multiplied by the radius squared. We can also work out the final linear acceleration at the center of the spool by subtracting the radius multiplied by the angular acceleration from the acceleration of the truck. Now, for subtask 2, it asks us to take a range of values and also consider the slipping condition, or possible slipping. So to work out the friction, we can take the coefficient of kinetic friction and multiply it by the normal force. So the normal force is achieved by multiplying the mass by gravity, and that's because it's a reaction force to the downward force of the spool. And if we want to get a range of values out of MATLAB, what we can do is create a loop that iterates through these calculations and increments up the values as it goes through the loop, and then achieve a range of outputs. Anyway, thank you very much.